Give the composition of copper matte. So most frequently asked this question, and the compositions will be Cu2S and Fe. Either process can be asked and which metal can be extracted from that method can also be asked. Okay, and which electrolyte which has been used in that process can also be asked. Practice the reaction so that you will understand how to write for the Monge process, Van Arcal process. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the Unit 6, the general principles and the process of isolation of elements. In this unit, we can expect one 1-mark question and one 3-mark question. So, hope you know that this is a inorganic chemistry, and in a part C, only we can expect the question from the inorganic chemistry only. So, only the inorganic chemistry chapters will come in the part C. Okay, there will be a no 5-mark question at all, and directly we can expect only the 3-mark and 2-mark question from this inorganic chemistry. Okay, let's see how the question will be arises in the 1-mark as well as in the 3-mark. Okay, so in the 1-mark question, always they can ask you the types of ore. Okay, and also they can ask you the question based upon the extraction, which metal is extracted from the which method, they can also ask you. Okay, so the question will be goes like this: name an important ore of aluminium. So what is the important ore of aluminium? It is a bauxite ore. Okay, like that the question can be asked. They can also ask the compositions of the ores. Okay, the composition of copper pyrite. Give the composition of copper pyrite. So it is CuFeS2. Coming into the next question, name an electrolyte which can be used in extraction of aluminium. So remember, they can also ask you the types of ores and the types of electrolyte which has been used and types of method which has been applied, which metal has been extracted, what is the composition of that ore, they can ask. Okay. So, in the extraction of the aluminium, the electrolyte which is used is molten aluminium oxide, cryolite and calcium fluoride, that is CaF2. Okay. Then, what are the product which is formed when the calcium carbonate is calcinated? So, when the calcium carbonate is heated, what will be the product? We all know that if the calcium carbonate which has been heated, it gives us to the calcium oxide and carbon dioxide. So, the products are calcium oxide and the carbon dioxide. Next question. Give the composition of copper matte. So, most frequently asked this question, and the compositions will be Cu2S and Fes. Next question, what do you mean by blisters of the coppers? The solidified copper which has been obtained has a blister appearance due to the evolution of sulfur dioxide, and that copper we call it as blister. So, the solid, the copper as we have obtained, it will be having some of the blister on its surface. It is having some of the holes on its surface. Why it is having some holes? To evaluate or to evolve the sulfur dioxide gas. Such copper we call it as blisters of copper. Okay. Next, which metal is refined by Van Arcal method, as I have explained? So, the titanium and zirconium are the two metal which has been extracted by Van Arcal method. Next, name the process usually employed for the purification of the nickel. For the purification of the nickel, there is a one method called as Mond's process. Okay, like this, either process can be asked and which metal can be extracted from that method can also be asked. Okay, and which electrolyte which has been used in that process can also be asked. Name the refined method used for silver and gold. So, there are two types of refining methods will be there, hydrolytic refining and electrolytic refining. So, electrolytic refining will be mainly used for refining of gold as well as with the silver. Which type of ore which is concentrated by froth flotation processes? So, in the froth flotation method, we have understood that only the sulfide forms of ore will be get concentrated by this method. We'll see with the 3 marks now. Okay. How is pure alumina is obtained from the bauxite by leaching process? So, already we know that leaching is a process where the ore which has been treated with a suitable reagent. Okay, that process we call it as leaching. So, how to obtain the alumina by the bauxite ore by leaching process we'll see now. So, for this reaction, you need to write the 3-step reaction mechanism along with one sentences. The first sentence is you need to say that the ores of alumina, it is nothing but a bauxite ore which has been treated with the suitable reagent known as sodium hydroxide to form a sodium aluminate. To form what? Sodium aluminate. Later, in the step 2, the solution of sodium aluminate which has been treated with or neutralized by the carbon dioxide to form a hydrated aluminium oxide with the formation of sodium bicarbonate. The precipitate of hydrated alumina are separated from the sodium bicarbonate by filtration, and this hydrated aluminium oxide which is upon heating at higher temperature around 1470 Kelvin to get a pure alumina with the evolution of water molecule. So, this is a process for the preparation of alumina from the bauxite ore by treating with the suitable reagent. Hence, it is known as what? Leaching process. In the exam, write the balanced 3-step reaction and with your own words, you can name the steps or you can write it in the sentences also. Next, explain zone refining. So, it is a refining process of the metal. Okay, and we have one principle for this. Let's see the principle of this method. The impurities are more stable in the molten state than in the solid state. That is the main principle behind this zone refining. So, what they'll do? They'll take the metal rod and also they'll take the circular heaters. We know that the metal can also be consist of many impurities. So, that from the starting point to the end, they will allow the circular heater to pass through it. If any impurities which is there in this metal rod or in the metal piece, so it will get solidified at the molten state. At the end of this rod, you know, the impurities will be get collected and later this process will be repeated many times in such a way that the impurities will be collected at the one end of the metal piece. After that, they will cut this metal piece and they will use it as a pure metal. This process of refining the metal which is known as what? Zone refining. Next, explain the Mond's process for the refining of nickel. So, the crude nickel which has been heated with a carbon monoxide to form a tetracarbonyl. To form what? Tetracarbonyl. This tetracarbonyl which is upon decomposition, you know, at very high temperature around 450 to 470 degrees Celsius to get a pure nickel with the release of carbon monoxide. Again, this carbon monoxide will be treated with the nickel to form a tetracarbonyl, and again that process will be undergo decomposition to give a pure nickel. This process will be continuous for the preparations of refining of nickel. Hence this process, which is known as what? Mons refining processes. Next question. Explain Van Arcal method for the refining of zirconium and titanium. So it is a Van Arcal processes. In this processes, the metals such as zirconium as well as with the titanium, which has been treated with the iodine to give a tetraiodide. So here I have shown the reaction with the zirconium, which has been treated with iodine to form a tetraiodine zirconium, which is nothing but a tetraiodide. Later this tetraiodide, which is upon heating, which gives rise to the zirconium with the release of iodine. Okay, this is one of the important method where the metal will be used in a space technology and it is purified by this method. Okay, only the zirconium and titanium will be refined by the Van Arcal method by using the iodine. Okay. Next question. Write down the reactions which are taking place at a different zone of the blast furnace during the extraction of the iron. So we know that in the extraction of the iron, there are 3-step zones will be created in the blast furnace. So the first zone is combustion zone, reduction zone and the slag zone or the slag formation zone. We'll see with the combustion zone and we'll see how the reactions will be taking place. At the bottom of the furnace, the carbon burns with hot air to give a carbon dioxide, and carbon dioxide moves upward and meets the more carbon to give a carbon monoxide. So what will happen? In the first step, the carbon combines with the oxygen to give a carbon dioxide. Later this carbon dioxide, further it will react when it is go upside, when it is become very hot, it moves upside and reacts with the remaining carbon to form a carbon monoxide, and this is a combustion zone. Whereas in the reduction zone, at the top of the furnace, the carbon monoxide will be reduces the iron oxide into iron. So you can see that you have taken the iron oxide. So the carbon monoxide which reduces the iron oxide into iron. Hence this process which is known as what? Reduction zone. In the last step, there is a slag formations will be there. The limestone will be decomposed to form a calcium oxide, which is combined with the silicon dioxide to form a silica. You can see that the calcium carbonate which has been added, which is nothing but a flux, which has upon decomposition to give a calcium oxide and carbon dioxide. This calcium oxide which is further reacts with the silicon dioxide to form a calcium silicate, which is nothing but a slag. So this slag will be collected over the molten iron and protect the molten iron not to react with the further oxygen to undergo oxidation. So these are the 3 steps which occurs at the blast furnace of the extraction of the iron. Next question. Draw the labeled diagram of Hall-Héroult electrolytic cell for the extraction of aluminium and write the anode and cathodic reaction. So we all know that the Hall-Héroult reaction or the electrolytic process, it is there for the extraction of the aluminium. For this reactions, for this process, you need to write at anode and cathode what types of reactions which is occurring. Okay, the purified aluminium oxide, which is nothing but a bauxite, which has been treated with sodium Na3Al(F3), which lowers the melting point and increases the conductivity of the melt. okay, and remember, which is nothing but a cryolite, okay. So at the anode, what will happen? The carbon reacts with an oxygen to give a carbon monoxide, and the electrons will be released, and you can see that at the anode, okay, you can see that this is a Hell-Hérold process for the extraction of the aluminium, and this is a large container which has been lined with a graphite which is acting like a cathode, and this is a carbon lining, you can remember it. And for this, you know, they have taken out the ore with a cryolite, okay, the ore which has been dissolved in a cryolite. So which ore we are taking? We are taking what? Al2O3, that is bauxite ore, which has been treated with a cryolite known as Na3Al(F6), which is a cryolite, okay. Why the cryolite will be added? Because which lowers the melting point of our ore, that is why it is used as a cryolite. So it has been suspended in this entire beaker. Meanwhile, they have placed a series of the electrodes, okay, and they are nothing but a graphite electrode, and it is acting like a anode. So what will happen? We know that the carbon which is lining which is there, you know, it will react with the oxygen to form a carbon monoxide. Later, that carbon monoxide will be goes for the reaction with the aluminium, okay. So at the cathode, the steel vessel with the carbon lining, you can see that, and the aluminium will lose 3 electrons and get reduced to aluminium, and overall cell reaction, you can see that aluminium oxide react with the carbon to give aluminium and carbon dioxide. So the aluminium react with the carbon monoxide to give a carbon dioxide and get reduced to aluminium. This is a process only for the preparation of alumina. So hope you are understood with the 1 mark and a 3 mark question from this unit. Remember, from this unit, only the 3 mark questions are very important. I have listed out all the maximum questions which has been frequently asked from this unit. Go through with all this question. Please practice the reaction so that you will understand how to write for the Mons process, Van Arcal process, as well as for the Hell-Hérold electrolytic process for the extraction of aluminium, and also the leaching process, which is one of the important process which has been asked repeatedly. So I'll come back with the next unit. Till then, take care, be safe. Thank you.